And we're on to the air mass lesson. Now, the objective for this lesson and the subsequent lessons, the lessons that follow, is this objective, EEN 2.5.2, explaining the formation of typical air masses and the weather systems that result from the air mass interactions. So this lesson, we're just going to talk about the formation of air masses. That's all this lesson is about. The lessons later this week will cover the weather systems and then the results when the air masses interact with each other. So we'll talk about that in future lessons. So let's ask the obvious question first is, what is an air mass? Well, an air mass is a large body of air whose properties of temperature and humidity are similar in any horizontal direction. Yeah, what? That's not a lot of information, and we kind of have to start picking it apart. So let's break it down. Let's look at some specific vocabulary in this definition that we need to define. Some of these you may already be familiar with. Some of these may be new. That's okay. Just refreshing your memory so that when we start pulling this apart, you'll understand what we're talking about. Temperature. That's kind of the easy one, right? It's how hot or cold things are. So we normally use Fahrenheit. So 32 degrees Fahrenheit is freezing. That's when it snows. We always look forward to that. Well, I do. Not everybody does. Or 0 degrees Celsius. From a science perspective, you should get comfortable in the Celsius world. But we are familiar with Fahrenheit because it's what we use every day. Humidity is something that I think a few people get confused about. And we're going to get into this a whole lot more in the future. Humidity is basically how much moisture is in the air. What's the water vapor content of the air? So when we are measuring humidity levels, we're basically saying of all the free space in the air between the air molecules, between the nitrogen, the oxygen, the carbon dioxide, all that free space that's between those molecules, how much of that space is filled up with water? Okay, so we measure humidity levels in percentages. Okay, it's the humidity levels at 50%, the humidity levels at 75%. The last couple of days, humidity level has been between 70 and 75%. The days that it rains, it's closer to 100%. So the idea is this. The higher the number, the more water is in the air. The more water is in the air, the warmer it's going to feel. So on a normal spring day, we usually have between 30 and 50% humidity. It feels really nice outside. The breeze, it could be 70 degrees outside, but the breeze makes it feel like a little chilly. You kind of want a jacket. 2 days later, we could have a front move in and the humidity level jumps to 75%. The last couple of days, humidity levels have been very high. You go outside, it's only 65 degrees outside, but it feels like it's 70 because there's so much moisture in the air that it makes it warmer. The more moisture, the more energy it absorbs. Water, remember we talked about water having the ability to have a high specific heat. It absorbs a lot of energy. So when that water vapor is in the air, it's absorbing a lot of energy, which means it's giving off heat. So humidity is a measurement of the water vapor that's in the air. The word similar, you guys get this. It's not something that's new for you. Similar is it's things that are close to each other, but they're not exactly the same. So if we're talking about, in this case, temperatures are similar, we're not talking about it's everywhere on where this body of air is located. So if there's a body of air over central North Carolina, it doesn't mean that Concord and Landis and Salisbury and Charlotte are all going to have exactly the same temperature. Okay, it doesn't mean that all of them will be 75 degrees. What it means is that they're going to be close to each other. So you're going to see Charlotte be at 78. You're going to be Concord and Salisbury be at 75. You're going to be Landis and China Grove, Mount Pleasant being 73. So the temperatures are going to be similar, but they're not going to be the same. And then, of course, what does horizontal direction mean? Well, remember, horizontal we think of as left and right. Okay, across something, not up and down. So here's a picture that shows the horizon, which is where the word horizontal comes from. Okay, that horizon is in the word. So if the horizon, you're looking out across the land at sunset and you see the horizon there, okay, that's horizontal. Think of horizon for horizontal. We're not talking about vertical air. We're not talking about what's at ground level and what's up in the sky. That's later. That's different. The air mass is what is along the ground. So the air mass that's over central North Carolina, the air that's in Concord, the temperature, the humidity levels that are in Concord, Charlotte, Mount Pleasant, Landis, China Grove, Salisbury. Those air masses, that, one big air mass. The temperatures are the same across that land, and the humidity levels are similar. Okay, so that's what an air mass is. So quick summary: a body of air that has similar, not the same, temperatures and humidity levels. That's the water vapor that's in the air along a horizontal direction. Now, this is a picture. This is out west. This is the person that took this is standing on Pikes Peak. It's 12,000 feet above sea level. And they're looking out across this little city you see. You can barely make out the city at the bottom there. That's Colorado Springs. And if you continue to look out, that's the plains. So this is a spot where the plains, the flatland, and the mountains meet. Okay? So when we are talking about a body of air that has similar temperatures, humidity levels along a horizontal direction, we're talking about that flat plain out there. All of that flat plain will have similar temperatures, will have similar humidity levels. Okay? The mountain itself will have different temperatures and different humidity levels because they're not on the same horizon. The flatlands here, the mountains up here, so they're in a different location as far as height, and their horizon is different. So the temperatures will be different and the humidity levels will be different. Okay? So when you're looking at a map and you see mountains, that's going to affect the air mass. If you see water, that's going to affect an air mass. So an air mass over water and an air mass over land can be different. That's why you can stand on the shore at the ocean, and it can be sunny where you're at, but you can look out in the ocean and you can see a storm out there. That's a different air mass. Okay, now let's talk about the types of air masses. We talked about what is an air mass, what makes it up, similar temperatures, similar humidity levels, similar horizon. For finding air mass types, there's only 4 types of air masses. Depending on where else you look online, they may come up with 6, but really those other types fit into these categories. So I'm just giving you the basic 4 categories of air masses. There's really 2 major categories, and then that 2 can be broken up into 2. So we'll talk about that. So a type of air mass is determined by where the air mass develops and what the temperature and the moisture is at the place of development. Okay? So, for starters, I know this is going to sound a little confusing, but let's try to put this together. For a cold air mass, cold air masses originate in the polar regions. So, Alaska, northern Canada, North Pole, South Pole, Antarctica. That's where these cold air masses start. That's where they make up. Okay, that's where they're located. Most cold air masses have colder temperatures and less moisture. Most. Okay, we call this a polar air mass. So when you are answering these questions that you're going to get in a minute, don't say cold air mass. You want to make sure you're using the vocabulary polar air mass. Okay, and we're going to go more specifically about that in a minute. So where it develops in the cold areas, the polar regions, determines if it's a cold air mass or not. Okay? Colder temperatures, less moisture usually. Okay? Then you have your warm air mass, which we call a tropical air mass. it usually originates in the tropical or subtropical regions. So tropical would be around the equator. Subtropical would be Florida, Texas, between the lines of, between the Tropic of Cancer and the Tropic of Capricorn. That would be subtropical. Okay? Flashing back to our discussion on lines. Generally, most tropical air masses are warmer temperatures, and they have more moisture. Usually. Okay? Now, when I say usually for both of those, this is why. There's a moist air mass. We call it a maritime air mass. There's a moist air mass called a maritime air mass. If that moist air mass forms over the oceans, which is where it gets its moisture from. And then there's the dry air mass, what we call a continental air mass, that forms over land surfaces. So we've got the cold air mass, which is the polar air mass. We've got the warm air mass, which is the tropical air mass. We've got the moist air mass, which is the maritime, and the dry air mass, which is the continental air mass. Let's talk about how the four of these air masses work together. Okay, so we said that the polar air mass forms in the polar regions. Okay, we said the tropical air mass forms in the tropics or the subtropics. We said a moist air mass, which is a maritime air mass, forms over the oceans. And a continental air mass is the dry air mass, and it forms over the continents or over a land mass. Okay? So, most polar air masses are continental polar. What does that mean? Okay? Continental means it forms over land. Polar means it forms over land that's in the polar regions. Alaska, northern Canada, and Antarctica. Okay? So if that's true, it forms over land and it forms in the colder air regions. How much moisture is it going to have? Well, it's forming over the continent. And most of the Earth's moisture is where? In the oceans. So it's forming over the continent, not the oceans. It's going to have a lower moisture level, lower humidity level. What's temperature is going to be like? Well, it's in the polar region, so obviously it's going to be colder. So the continental polar is most of the polar air masses that we have. Okay, so it's dry and it's cold. The maritime polar, now based off of what we just said, what do you think about this one? Well, the polar gives us a way that it forms where? Up north, okay? Or down south, down at the Antarctica, okay, in the polar regions. But where in the polar regions does it form? Maritime tells us it forms over the ocean. Now, this is where it gets a little confusing. Continental is colder and drier. Maritime is warmer and moister, has more moisture. It still forms in the polar regions, so the temperatures are still going to be cold, but a maritime polar air mass is going to be a little warmer than a continental polar air mass, because usually the ocean is warmer than the land. So it's going to make things a little more comfortable, because it's bringing in a little more moisture, and it's bringing in a little more warmth. But most of our polar air masses are continental polar air masses. Now, just the opposite of the polar, the tropical air masses, most tropical air masses are maritime. Okay, so what does that tell us about temperature and moisture? Okay, maritime forms where? Over the oceans, in the tropical areas. Good. Okay, so what's our moisture level like? It's going to be higher because it forms over the ocean. What's the temperature going to be like? Okay, because it's tropical, it's going to be warmer. So, you're talking 60s, 70s, 80s tropical air mass. Okay? That's most tropical air masses, maritime tropical. So there's a lot of moisture and warm temperatures. We get to continental tropical. Where does this form? Over land. But it still forms in a tropical area. So that means the temperatures are still going to be, they're actually going to be higher. Okay? But the continental tropical forms usually over deserts. So it's going to be high temperatures, low moisture, low humidity. Okay? So continental, polar, low temperatures, low moisture. Maritime polar, a little bit higher temperature, still cold, more moisture. Maritime tropical, lots of moisture and warm temperatures. Continental tropical, little moisture and really hot temperatures, warm temperatures. So there's, when I say 4, that's what I mean by 4. Continental polar, maritime tropical, continental tropical. So let's see how you do with understanding this, okay? I'm going to have an AirMass check-in set up for you. Go ahead and take the AirMass check-in. If you do not score 80% or higher, come back and rewatch the video. Send me a message. I'll unlock it for you to take a second time. Okay, the goal is 80%. Goal is 80%. If you need any help, come find me on Microsoft Teams and have a good day.